Okay, gang, the SD card cut me off, so we had taken the derivative here. I was simplifying the derivative, and I would just suggest you go another step here. You take out the common factor. So the common factor would have been x e to the negative x. So in the front here we would have been left with negative x, and in the back part we would have been left with plus 2. So it actually, when it comes out like that, it actually looks better if you write it as 2 minus x, but it doesn't matter. Okay, so you just sort of want to simplify that a little bit and get something like that. Alright, gang, we cover a lot of stuff, and I'm not expecting you to know this for the test, but I want to just go over it briefly because some of you are going to end up being engineers and mathematicians, and I just want to make sure you get the full understanding of the material. So when we talked about the e to the x, the derivative is more straightforward than for base e than it is for other bases. If it's something that's not base e, like 5 to the x, then the derivative is ln a to the x. So for instance, if you're taking the derivative of 5 to the x, if it's not base e, it's ln a, which means the natural log of the base. So it's ln 5 times the function itself, 5x. So the reason why you don't see this ln part for the e is that if you take ln of e, what is that going to be? Ln of e is going to be 1, right? So this part will go to 1 every time in the basic e case. Now the second part is just saying, well, what if you had a composite? So like, for instance, this one's a composite. So it's just a little more complicated, but very similar. Sometimes I write it like this, sometimes I write it like this. This is like more of an action, like this says I'm taking the derivative of that. Alright, so if we do this one, you can see it's still ln of the base, so the base is still 5 in this example. Then it's the original function, which you're used to with this, with the e, you're used to it being the original function. And then this says take the derivative of the inner layer. This, you could think of this as u prime if you don't like the notation here. So that would then be the derivative of that, which is negative 1. So you guys are used to these last two steps, you're just not used to the first one. Right, and these answers always look weird when it's not base E. They're more complicated looking. Okay, so that's good to know it. I may decide to give an extra credit for those people who want to try this. You know, until I write the test, I don't know, but again, if you're engineering, mathematics, please take note of this. The rest of you, if I give it, it'll be extra credit. I know I'm already doing a lot of stuff. Okay, let's now, so we did E, so okay, so for this part, we already did E, so it's the first thing I want you to know. And then I sort of have to flip around here. Give me a second to find the next. This is actually in 3.4, but it's, in my notes, it's a little farther away. Okay. Alright, so we're still in 3.4. Now this, you have to know, this is your logarithm. You know, this video is already at 4 minutes, so let me just start the next one fresh. I'll come back and we'll start this guy fresh. I'll catch you. Bye-bye.